Welcome to Python for Introductory Statistics. In this video, you will learn how to do hypothesis testing for proportions. Let's look at this example. The mayor of a city believes that more than 60% of the residents are fully vaccinated for COVID-19. In a survey of 120 residents, 81 were fully vaccinated. Test the mayor's claim at alpha level of 0.05. Now, this is about proportions. So the claim is more than, so the word more than gives you the alternative. So more than 60. So therefore, the proportion is 60 for the null and more than 60%, which 0.6 in decimals is the alternative. Now, what we're given is the null proportion, the proportion in the null hypothesis is 60. Now we're going to use letters X and N. N is the sample size, which is 120. And X is going to be the number of people, in this case, fully vaccinated. So we're using the letter X. It's very common, but it just means those who said yes. So they will be asked, are you vaccinated? Yes. It could be another context. And that's how we decide X. Again, in this example, because the mayor is claiming more than 60%, the alternative is greater. So now let's copy and paste the function that will help us with this question. So that's in chapter 10. In chapter 11, we're dealing with hypothesis testing for proportion zeta, so 11.3. We need to copy and paste this function right here. So let's copy this and bring it um, into our code. Let's make a new code here and then copy and paste. All right, it's running well. So now let's copy the name of the function, right? So we can avoid a typing error. So copy the name of the function and paste it in a new code here that will provide the information that we have. So for the null, the proportion is 0.6. Okay. Now, how many said yes? I believe, yeah, 81 out of 121 out of 120. So 81 is X and N is 120, right? X is 120. And then it's greater. So the alternative is not two-sided, but it's greater. And let's run this code, and it gives us just two information. The z statistic value is 1.677, and the p-value is 0.046, which is still less than 0.05, and therefore you would reject the null hypothesis.